Also, one of the updates of the iPad was that it can solve math equations now. Like, not like full-fledged math equations, but there may be things that I put up and it like throws an answer up there, so it's going to be interesting to see. I may have to go turn that function off because I was playing with it the other day and I was like, whoa, like, I don't know if it'll do it at this moment, but when I did this the other day, okay. Oh, yes. It'll try to solve things. So, it'll be interesting to see what happens, but all right, so we're jumping because we had kind of stopped at like, I think it was number 30. So we're jumping all the way down to number 46. X minus the square root. Oh, stop.
Can I get my notebook out of my locker?
Yeah. The square root of 3x plus 18 equals 0. Okay, this is going to get really annoying really fast. Please stop trying to solve an equation. Thanks. I'm going to have to turn that off. It also can only solve like very basic equations, which I feel like defeats the whole purpose. Like, I feel like it should be able to solve like 2x plus 3 equals 5, and it can't. But anyways. Okay, so when we have a equation like this, we're going to move this stuff over. Basically, I want to get the radical by itself, which is not exactly what we would, like, normally we would try to get x by itself, but I have an x in the radical, so I'm going to get the radical by itself. So negative square root of 3x plus 18 equals negative x. Divide by the negative. The square root of 3x plus 18 equals x. I need to figure out how to turn this off. This is going to drive me crazy. Off. Okay. There we go. So, when I have this, I get to a square root on one side and then, like, you know, something else on the other side. I square both sides to get rid of the square root. So, I don't usually write it like this, like, but just for the visual so we can see it. So, this would become 3x plus 18 equals x squared. I'm going to move this stuff over because I'm ultimately trying to solve and figure out what x is. So 0 equals x squared minus 3x minus 18. And now I need to factor that. Any idea what it's going to factor into?
Which one?
The problem that we're on.
6 and 3.
6 and 3. What are the signs on those though?
Negative 6, +3.
-6, +3. So since there's nothing in front, I don't have to do like the art, like, well, I mean, it's still kind of the arch method, but I don't have to like write it out like that. So I can actually just go straight to x minus 6 and x plus 3 like that. Then take each piece and set it equal to 0. So x minus 6 equals 0. X plus 3 equals 0. X equals 6, x equals -3, then would be your two answers on this one. All right, number 50. Square root of 6x plus 7, and then outside the square root minus 9 equals x minus 7. So if it's possible, I want to get the square root by itself. When we get to problems that have a square root on both sides, that's not always going to be possible. So just be aware of that. But in this one I can, so I'm going to move the 9 over. So I'll have the square root of 6x plus 7 equals x, what's that, plus 2. So then when I square both sides, I need to be mindful that over here, I need to put this stuff in parentheses and square it. I'm not squaring each piece individually, I'm squaring that as a whole. So this is going to give me over here 6x plus 7 equals, now this is a perfect square trinomial, so I need to basically like FOIL this out. So I would get x squared plus 4x plus 4, and then move everything over. So 0 equals x squared minus 2x minus 3. And now I need to factor this. What would the factors of this one be? Negative 3 and positive 1, so x minus 3 and x plus 1. So then x minus 3 equals 0, x plus 1 equals 0. So x equals 3, x equals negative 1.
Good question. So you know how at the start how it was equal to x minus 7? So how did it turn into x plus 2?
So I added the 9 over.
Oh, okay. Thank you.
Let's see. All right, so those ones, obviously we only had one radical we were dealing with. I'm going to jump down and do one for you that has a radical on both sides. So we see what's going on with one like that. So number 56, square root of x plus 5 outside the square root plus 2 equals the square root of x minus 1. All right, so normally we want the square root by itself, but I have two of them, so I can't get, by themselves entirely because there's another number being added. If it was just like, say this plus 2 wasn't here, and it was just that one's equal to that one, well, we would just square both sides and solve. But this added plus 2 makes it a little bit more difficult. So when I go to square both sides, I have to square this piece entirely and then this piece over here. So this is now the same thing as me saying I have the square root of x plus 5 plus 2 times the square root of x plus 5 plus 2 is equal to x minus 1, because that one's square root and square just cancel. So I need to go through and FOIL this, and obviously it's a perfect square trinomial like the previous one, but I think it's easier to see this one, like, to multiply it out. So first terms, when I multiply the square root of x plus 5 times the square root of x plus 5, that's literally just saying the square root of x plus 5 squared, which would just be x plus 5. So that's the first part. And then I've got 2 times the square root of x plus 5 plus 2 times the square root of x plus 5. So that's going to be 4 times the square root of x plus 5. And then finally, 2 times 2 is 4, so plus 4 equals x minus 1. So now what I want to do is I want to get the like terms combined on the left, and then I'm going to ultimately move stuff over to get the radical by itself again. So I now have to get the single radical by itself. So over here I've got x plus 9 plus 4 square root of x plus 5 equals x minus 1. I'm going to subtract the x and I'm going to subtract the 9. So I have 4 times the square root of x plus 5 equals, x minus x is just gone, negative 1 minus 9 would be negative 10. I'm going to go ahead and divide by 4 because I need that radical by itself. So x plus 5, or square root of x plus 5, is equal to negative 10 over 4, which would reduce to what?
-5/2.
Yep, negative 5 over 2. So now at this point, I can square both sides. I've gotten this radical by itself now. So I've gone from having 2 radicals to having 1, and now I'm going to go to no radical. So square that, square this. X plus 5 equals, negative is going to be squared, so it's going to become positive. So 25 over 4. I need to subtract the 5. I'm going to rewrite this 5 as 20 over 4. Do you know why? Yep, I need to have a same denominator. So x equals 25 over 4 minus 20 over 4, which was previously 5 in case we need a reference. So my final answer would be x equals 5 over 4. So a lot more work on the ones like this, but it's not too bad. Okay, the instructions still say solve the equation, but it's a different set of problems, just so you know. Number 76, I've got x to the 5 over 4 equals 32. So with a problem like this, what I'm doing is I need to think about what's happening so that I can undo it and just get x by itself. So what does this exponent of 5 over 4 mean that I'm doing? It's a 4th root, and what does the 5 do? 4th root to the 5th power. So a lot of times, for myself, I'll go through and I'll rewrite it. So the 4th root of x to the 5th equals 32. Now, I need to undo this, okay? Now, I'm going to be honest. Ultimately, how do I undo this? I'm going to raise it to the 4th power, and I'm going to take the 5th root. But do you know what 32 to the 4th power is off the top of your head? No. Maybe not. Probably not. So what I do is I'll actually do the, undo the power first. So I would take the 5th root first. So you would have the 4th root of x is equal to, what is the 5th root of 32? 2. So then now I've got the 4th root of x. I need to undo that by raising it to the 4th power. So I would have x equals 16. So the other way that sometimes I'll do this problem is I'll say, I wrote it this way just for reference. I wouldn't normally go about probably writing it like this, but I'll say, okay, well, I know x is being raised to the 5th power and then the 4th root of that. So from here, what I'll often do is say, okay, well, x to the 1/4 equals the 5th root of 32, and then I'll solve that. And so then I'll say, I'll raise it to the power, x equals 2 to the 4th power, and then go to x equals 16. So you can also do it that way if you want. I was just doing it this way to make sure we know what that means as an exponent. Any questions on that one? Okay. Let's see. Let's look at 80. I have x plus 200 raised to the 2/3 equals 36. Any idea where I should start with this one? Pretend this stuff isn't in parentheses. Like, pretend that it's just, like, x, like in the previous one. What would you tell me to do if it was just, like, x?
Do the third root. Wait. Yeah, third root. Like square.
Oh, so you want me to write it like this?
Yeah, do that.
Okay. Okay. Equals. Now, this is really going to be x plus 200, so I'm going to rewrite this so that we're not confused. Okay. Now what? Huh? So it was being squared over here, so to undo a square, what do I have to do?
Square root.
Square root. So this is going to be the cube root of x plus 200. So I've undone that. So is equal to the square root of 36, which is also known as 6. So now how do I undo a cube root? Cube it. So x plus 200 equals 6 cubed. What's 6 cubed?
I was close.
216. So x plus 200 equals 216. Now at this point I can just subtract, so x equals 16. Any questions on those? All right. Then in addition to the problems that I assigned to you on Friday, and we have about 30 minutes left, so you should have plenty of time to get them done, I'm going to add on number 45. Nope, I lied. Not 45. Yeah, 45 is fine. 55. 75 and 79. So that in addition to the ones that I gave you on Friday, and then you'll turn all that in together. Tomorrow we'll do review for a quiz on 1.4 part 2, so where we left off before the last quiz, we'll pick up there for a quiz on Wednesday, and then we're testing on Friday so that you'll have another test grade in there.
So we turn the homework in